Hello student, this is my lecture number 3 of the topic Electrochemistry for class 12. This is the continuous part from previous lecture 2. In earlier segment we have a study about the Faraday law of electrolysis, and there is problem related to this. Problem is that a solution of copper sulfate is electrolyzed for 10 minutes with a current of 1.5 ampere. What is the mass deposited at cathode? As we know, copper sulfate, CuSO4, which undergoes electrolysis, then it forms Cu plus 2, then SO4 minus 2. As we know, copper plus 2 ion is there. So copper plus 2 ion, when it is neutralized, it requires 2 electrons. Then it forms CuS. It means 2 into 96,500 Coulomb. 1 farad is equal to 96,500 Coulomb, that is 2 farad. As we know, 10 minutes time is 10 minutes. When converted to second, 10 into 60, and I current is 1.5 ampere. So that charge supply is I into T, that is 1.5 into 10 into 60, that is 900 Coulomb. As we know, this charge, according to question, 2 into 96,500 Coulomb charge, in which copper, mass of copper is 63.5 gram. So at 1 Coulomb, the mass is 63.5 divided by 2 into 96,500 Coulomb. When the charge supply at 900, then it is 63.5 by 2 into 96500 into 900 Coulomb. Now, this is the answer. Now, second question is that how many Coulomb of electricity, how many Coulomb of electricity are required for complete reduction of 100 ml of 0.1 molar KFnO4 solution. As we know, this is the molar, 0.1 molar KMnO4 solution. It means which is undergoes reduction. When potassium permanganate, which is undergoes reductions in presence of acidic medium, then it convert into 5 electron Mn plus 2 plus 4H2. that is 5 Faraday. That is 5 into 96,500 Coulomb. As we know, that is 100 ml of K1O4 whose concentration is 0.1 mole. 1 K1O4 concentration is 0.1 divided by 1000. If the 100 ml of K1O4 whose concentration is 0.1 divided by 1000 into 100, that is 0.01. So that charge required for the reduction is equal to 5 1 mole of reduction required 5 into 96,500 Coulomb. इसलिए 0.01 mole it required 5 into 96,500 into 0.01, that is 5 into 965 Coulomb. This is the answer. Now we have discussed the another topic, that is conduction. Conduct. C-O-N, conduct. D-C-O-N-D-U-C-T, conduction. Conductance. We have discussed the conductance. Conductance is those property, and conductance are those properties in which properties of substance which allow to flow of electrons, that is current. Conductance, it can be classified into two types. First one is electronic. Conductance. This is example of metal. Metal is an example of electronic conductance. These type of substances which flow of current without any decomposition, without change their decompositions. Second point is that what are the factors which depends? It depends upon the nature of nature of substances as well as its valence electron. Second factor is that, this is the first factor. Second factor is that temperature. As temperature increases, conductance decreases due to which hindered the flow of electrons due to vibration of its mobile electrons of metal. So temperature which influence the electronic conductance. Now second example, that is known as electrolytic conductance. Second example is that this is electrolytic conductance. These substances which allow to flow of current due to decomposition of an electrolyte in aqueous molten medium, like that example of all acids and bases, salts are example of electrolytic conductance. First of all, what is electrolyte? Electrolyte are those substances. Electrolyte are those substances which allow to flow of current. These are two types: a strong electrolyte, a strong electrolyte. It decomposes that is dissociation takes place easily. All strong acid like H2SO4, it decomposes in aqueous medium as positive at HSO4 negative. Similarly, NaOH it decompose Na plus OH minus, like salt of NaCl. This is also example of a strong electrolyte. So it can form the strong acid as well as strong base. Na plus aqueous plus Cl minus aqueous.